Comparison of amplitude modulation with the double sideband suppressed carrier and the single sideband suppressed carrier AM. For amplitude modulation, it is nothing but a double sideband full carrier amplitude modulation, traditional amplitude modulation. So, for traditional amplitude modulation, we have the bandwidth is twice of the modulating signal frequencies and a 2 FM. Bandwidth is 2 FM, here also 2 FM, here also 2 FM. For a double sideband suppressed carrier amplitude modulation, also bandwidth is 2 FM. For single sideband suppressed carrier amplitude modulation, bandwidth is 2 FM. Then for AM signal contains USB, LSB and carrier signal. For double sideband suppressed carrier is suppressed in this. So it contains only sidebands, two sidebands, upper sideband and lower sideband. So this is single sideband suppressed carrier. So it contains only USB or LSB with the carrier. Here more power is required for transmission. For AM signal we need more power. Power required is less than the AM signal. Power required is less than that of AM and double sideband suppressed carrier AM. So this is a simple comparison of AM and double sideband suppressed carrier AM and single sideband suppressed carrier AM. What are the advantages of angle modulation over amplitude modulation? The amplitude of FM is constant, okay? For frequency modulation, amplitude is constant, then it is independent of depth of modulation. Hence, the transmitted power remains constant in FM. Noise interference is minimum in FM, whereas it is difficult to remove in amplitude modulation, isn't it? Due to the amplitude variation. Because in FM, we don't have any amplitude variation. But in the amplitude modulation, we have the amplitude variation in the signal. So it is very difficult. Noise interference is more in amplitude modulation than that of frequency modulation. Long distance communication is possible due to large bandwidth, whereas in AM has lower bandwidth, so applicable to short distance communication. So FM is applicable for long distance communication due to large bandwidth, whereas in AM lower bandwidth, so it is applicable to short distance communication. See, this is the differentiation between narrowband FM and wideband FM. So wideband frequency modulation, narrowband frequency modulation. For wideband frequency modulation, modulation index is greater than 1. For narrowband frequency modulation, modulation index is less than 1. Here the frequency deviation is 75 kHz. Here the frequency deviation is 5 kHz. Modulating frequency is equal to 30 Hz to 15 kHz for wideband frequency modulation. For narrowband frequency modulation, modulating frequency range is 3 kHz. Here the bandwidth is 15 times the narrowband frequency F. Here the bandwidth is equal to twice of the frequency modulation. Noise is more suppressed here, less suppressing of noise. So this can be used for entertainment and broadcasting. Then narrowband FM can be used for mobile communication. So this is the differentiation between wideband frequency FM and narrowband frequency modulation. Define signal to noise ratio. It is the ratio of signal power to the noise power at the same point in the system. It is denoted by SNR. SNR or S by N. Signal to noise ratio. It is nothing but the ratio between the signal power and the noise power. The noise factor and noise figure. Define noise factor and noise figure. Noise factor is denoted by a letter capital F. Noise factor. It is nothing but a signal to noise ratio at the input divided by signal to noise ratio at the output. Ratio between the signal to noise ratio at the input and the signal to noise ratio at the output. So ratio between these two will give the noise factor. The noise factor, noise figure is, if the noise factor is expressed in decibel, it is known as noise figure. It is nothing but noise figure capital F is equal to 10 log of F, noise figure. Then noise temperature definition. Define noise temperature. The noise power is respected in terms of temperature is called noise temperature. Noise power is represented in terms of temperature. Noise power is represented in terms of temperature is called as noise temperature. This is not respected, this is represented. Sorry, I made a mistake. The noise power is represented in terms of temperature is called the noise temperature. That is, the noise power is directly proportional to the temperature. That is, temperature TE is equal to capital F minus 1 into capital T, where TE is equivalent to noise temperature. TE is nothing but equivalent to noise temperature, and the capital T is an absolute temperature. Okay, so if the noise power is represented in terms of temperature, is nothing but noise temperature. Carson rule. The minimum bandwidth of angle modulated wave of angle modulated wave is twice the sum of the peak frequency deviation and the highest modulating signal frequency. It's nothing but bandwidth for FM is equal to twice the peak frequency deviation del F and maximum modulating frequency. Sum of the peak frequency deviation and maximum modulating frequency. So this is the bandwidth for FM. So bandwidth for FM is nothing but twice the frequency deviation plus maximum modulating frequency. So this is called as Carson rule. Then now we are going to write the definition for bandwidth efficiency. Bandwidth efficiency. It refers to the information rate which can be transmitted over a given bandwidth in a specified communication system. Is nothing but bandwidth efficiency. Other name for bandwidth efficiency is nothing but other name for bandwidth efficiency is spectral efficiency and spectrum efficiency. All are same. So bandwidth efficiency is also called as spectral efficiency or spectrum efficiency. It's nothing but the information rate can be transmitted over a given bandwidth.